Now let's look at the next topic in polynomials. So this is the factor theorem. It's somewhat related to the remainder theorem. So let's look at what it is actually. So for any polynomial p of x, if k is a 0 of p of x, that implies that x minus k is a factor of p of x. We already know that. So, but the factor theorem comes into the picture when we are trying to figure out whether a polynomial has a factor. So we can figure that out without having to do the long division method. So what you do is you you do the same thing as the remainder theorem, except if you get a value of 0, which is the remainder, it means that it is a factor. So like that's what factor remainder theorem essentially is. So if k is a 0 of the polynomial, then p of k will be 0, meaning that the remainder will be 0 and p of x will just be this. And essentially it shows that x minus k is a factor of p of x. Now let's look at a worked example to see how it really plays. So if 2x minus 1 is a factor of this, and the remainder when f of x is divided by x minus 1 is minus 1, find the values of a and b. So without looking at the solution, we'll just look at the question first and we'll see what we're supposed to do. Since this is a factor, that means p of 1 by 2, or in this case f of 1 by 2 will be 0, since the remainder must be 0, and that's what they have done. And then you like substitute the values, and then you just find a simplified equation in terms of a and b. So that's going to be our first. I would have just written b equals 1 by 2 minus 1 by 2a. So, and then next it states that when it's divided by x minus 1, the remainder is minus 1. So that means f of 1 will be negative 1. So we form another equation using this statement. So we have two equations right now. So upon solving it simultaneously, we get the value of a and b. So over here, they have multiplied the first equation by 2 to make sure a and the value of a here and the value of a here remain the same, and like the coefficient. So you can like cancel them out, and then they just simplified, and then they get b equals 2. And when you substitute this back into the equation, we get a equals minus 3. So that's how this theorem works. So you can get questions based on the remainder theorem and the factor theorem, or just like remainder theorem or just factor theorem. So now that we have understood what the remainder theorem is, and we have looked at the sort example, now let us actually go on to solving them. Take a few minutes to solve this. For these two questions, let's determine whether, and then the thing. So take a few minutes to solve it, then I will solve it after you're finished. So just unpause the video after you're done. And yeah, okay. So now let's go on to the problem. So let's start. Okay, so we have to determine whether x minus 1 is a factor of 4x cubed minus 7x squared plus 5x minus 2. So how do we do that? We use the factor theorem. So if p of 1 equals 0, that means this is a factor of this. So let's do that. Let f of x equal 4x cubed minus 7x squared plus 5x minus 2. So if f of 1 equals 0, that means it is indeed a factor. So this is going to be 4 minus 7 plus 5 minus 2. This is going to be 9 minus 9. So 4 plus 5, 9, minus 7 minus 2 minus 9. So this is 0. So it is a factor. Now let's move on to this question. So we'll see if this is a factor. So let p of x equal 3x cubed plus 5x squared minus 6x minus 8. So p of minus 2 equals 3 into negative 8 plus 5 into 4 plus 12 minus 8. So this is negative 24. This is plus 20 plus 4. So that's negative 24 plus 24. That is 0. So this is also a factor. So x plus 2 is also a factor of the polynomial. Let's move on to the next question. So it's this. Let's take a minute to read it. So find C given that x plus 1 is a factor of this polynomial. So let's say g of x equals 5x cubed minus 3x squared plus cx plus 10. So it's given that this is a factor. So g of minus 1 equals 0. So 5 into negative 1, negative 3, negative c plus 10 equals 0. So negative 5, negative 3 plus 10 equals c. So c equals 10 minus 8, which is 2. So now let's plug this back into the equation. So this is our equation, our polynomial, and let's actually do the long division to make sure that we got the right answer. So the divisor here, the polynomial inside, okay, and now let's do the long division. Since the remainder is 0, we got the right answer for the value of c. So this is how you do it. So let's solve the last question. So let's read the question. X plus 2 is a factor of p of x, which is 2x cubed plus x squared plus kx minus 4. So we have to find the value of k, and then we have to write p of x as a product of linear functions. So let's do that. Okay, so we know that p of minus 2 will be 0. So into minus 8 plus 4 negative 2k minus 4 equals 0. 16, 4 and 4 get cancelled, so 2k equals negative 16 and k equals negative 8. So and now p of x equals 2x cubed plus x squared negative 8k minus 4. Now let's do the long division to write this as a product of linear factors. So let's divide this by x plus 2. So therefore p of x equals x plus 2 into 2x squared minus 3x minus 2. We can split the middle term and write this. So this is our final answer. We have written this in the form of linear products. So that's all for this chapter. So the chapter polynomials is done, and hopefully it was helpful. And stay tuned for the next chapter, which is gonna come out in a couple of days.